Hello, and welcome to our trigonometry adventure. Today we are exploring the abandoned boat of the Titanic, and we need to use trigonometry to complete this expedition. We first need to understand what trigonometry is. So here is the intro. Trig functions are used to find angles, and there are three primary functions: sine, cosine, and tangent. Each have different properties. Sine of theta equals opposite over hypotenuse. Cosine of theta equals adjacent over hypotenuse, and tangent of theta equals opposite over adjacent. This is also known as SOHCAHTOA, which is a simple way to remember these functions. Now that we know what SOHCAHTOA is, let's put it in play. So when you're given a right triangle, you have to label the sides according to the angle. Opposite from the angle is the opposite, next to it is adjacent, and across from the right angle is hypotenuse. And these tools will help us with our first problem. So the first problem we ran into was how far do we have to swim to reach the boat if our anchor is 11,000 meters up from the seafloor and our angle monitor tells us that we are looking down at the boat at a 32-degree angle. I drew out a picture so it's easier to visualize. And the first step is to label each side according to the angle. The sides we're dealing with is adjacent and hypotenuse. And we look back at our trig functions, and that's going to be cosine. So we start out the problem by setting cosine of 32 is equal to 11,000 meters over x. And so the cosine of 32 is equal to 0.848, and then you multiply x on either side, and then divide by 0.848, which gets you to x is equal to 12,971 meters. So this means that we have to swim 12,971 meters to reach the boat. And we use this answer in our next problem. The next problem we face is how far does our boat need to travel in order to be directly above the Titanic? We started off the problem the same way. Our angle monitor still reads 32 degrees, and we now know we have to swim 12,971 meters to reach the boat. Now we know which sides we're dealing with, we can assume that we are going to use the sine ratio. So the sine of 32 degrees is equal to x over 12,971 meters. We then multiplied by 12,971 meters, and then once you put that into your calculator, you will get x is equal to 6,873.6 meters. Now we know how far our boat has to be in order to be directly above the Titanic.
Today we're going to be learning about inverse trigonometry. Inverse trigonometry is used when you're given two side lengths and you want to find an angle. You still use the sine, cosine, and tangent ratios when using inverse trigonometry to find an angle. For example, inverse sine of opposite over hypotenuse equals theta, as well as inverse cosine of adjacent over hypotenuse equals theta, and inverse tangent of opposite over adjacent also equals theta. This is going to help us when we run into our next problem about the Titanic. If we are anchored in a shallower part of 9,500 meters up from sea level, and we know that the Titanic is 5,000 meters from our anchor, what angle is our boat at? First, I drew out the problem so that you can get a better understanding of what is happening, and don't forget to put your calculator in degree mode. Our first step is to figure out what trig function we need to use, and we do this by labeling our sides. We know that our opposite side is 5,000 meters, and our adjacent side is 9,500 meters, so this means that we can use inverse tangent to find the unknown angle. Inverse tangent of opposite over adjacent is equal to theta, so we are going to do inverse tangent of 5,000 meters over 9,500 meters equals theta. When you plug this into your calculator, theta will be equal to 27.8 degrees.
By using inverse trig, we were able to figure out what angle our boat should be at when reaching the Titanic.